Yeah. Today we will discuss about the one second. We require micro partitions. We require subsets. We require custom. Fine. That's it. Chalo. Guys, we will discuss today Snowflake architecture. If you get any queries, in between, better we will discuss all the queries at the end of the session so that we will not miss the continuity. So that is my intention. See, we will be in the flow while explaining something. If I get in between something, then we will miss that continuity. That's it. We will discuss all the general queries or topic related queries at end of the session. That's fine. See now, Bhavana, have you gone through the yesterday recording session?
No, Shekhar. This morning 6:55 I got the demo link.
That's fine, but there is no much link between yesterday's session and then today's session. If you go through yesterday's session, then you will get the all the content. But I will try to explain from the ground level where you all should not get any gap while explaining. Fine.
Oh yeah, sure. Thank you.
See, we have a three layers in Snowflake architecture. One is cloud service layer, another one is query processing layer, another one is database storage layer. So this architecture is very important and you need to understand thoroughly, and you will be getting one or two questions from Snowflake architecture in the interviews. So while explaining, better to note some few points, and I can say running notes. Better to prepare some running notes while explaining, then it will be good practice. Fine, let's chalo. We'll start one by one. So we have a three layers in Snowflake architecture: cloud service layer, and then query processing layer, and then database layer. We'll start from the database layer. What is this database storage layer? What is this database storage layer in Snowflake? Actually, whatever the data we are going to load into the Snowflake, automatically the data will be stored in a Snowflake in multiple micro partitions. Suppose let's consider I have a example. I have a table called customer. We are loading a huge data into the customer table into the Snowflake from the different source file. Once we load the data into the Snowflake, internally what will happen? We can't see those things under. Internally what will happen? The data will be stored in a continuous multiple micro partitions. I will tell you what is that micro partition. Suppose this is the storage component in Snowflake. This is the least storage component in a Snowflake where your data is going to resides or store in a Snowflake. Let's start. So this is a, suppose let's consider this is our table. This is our table. We are going to load the data into this table. Whenever we load the data into this table, if you check the data from the table, select star from some customer table, you will be able to see the data in combination of rows and columns only. But whatever the data is going to store in the internally, that is different. Whatever we are going to see, the data, if you write a query select star from table, in a traditional format only, we can able to see in the combination of rows and columns. But the storing internally in the Snowflake is different. That we will discuss as part of the storage layer. When we load the data into the table, the data will be stored in the form of micro partitions. Data will be stored in the form of micro partitions, multiple continuous micro partitions. And also, when you load the data into the Snowflake, the data will be stored in a compressed format. Compressed format means what? It will compress the data. Suppose if you are loading a 1 GB of data into the Snowflake, if the data is compressed, it may become a 900 MB. So always it will take the storage capacity less than the actual size of the data. If you try to load the data, 1 GB of data into the Snowflake environment, while storing a data, it will compress and it will store the data, so that it will consume the always less than the storage space than the actual size. What is the benefit of this means? What is the benefit of this means? You are going to save the cost to the organization, because the pricing will happen on the Snowflake based on the storage and then based on the your virtual warehouse. That part we will discuss later. That part we will discuss the later. Whenever the data is going to store in the multiple micro partitions, suppose let's consider this table data is stored in a this data is stored in a multiple micro partitions, micro partition 1, micro partition 2, micro partition 3, and then micro partition 4. Fine. Even in micro partition also, so they will, even in micro partition also, so it will be having a track of the records. How many records it will be having a track of the records. How many records one micro partition has stored. So here rows 1 to 6, first micro partitions 1 to 6, 1, 2, 3, 4, 5, 6. And then micro partition 2, rows 7 to 12, like that. And then micro partition 3, so and then 13 to 18. Micro partition 4, 19 to 24. Now the question is, what is the benefit? What is the benefit to store the data into the micro partition? And also one more important thing is, in the Snowflake, data is going to store in a column format. Data is going to store in a column format, not into row format, not into column into format. In our traditional database, the data will be stored in a rows and column format. But in Snowflake, the data will be stored in a column format. I will tell you what is the benefit. The data is stored in a micro partitions if the data is stored in a column format. Let's focus on the micro partitions. What is the advantage here? I will tell you guys. See here, when the data is stored in a multiple micro partitions, and then see, this is your table and data, and this data is treated in a multiple micro partitions, continuous micro partitions. Whenever you load the data into the table and the data is going to store in the micro partitions, this micro partitions details will be available in somewhere in the metadata tables in the Snowflake. Nothing but in metadata tables, the metadata will be available for the particular table. Nothing but this table has occupied these many micro partitions. The micro partitions numbers are this, and then these micro partitions are having a rows from this number to that number. Now, when you query a data from the particular table, these things will happen in the internally. When you query a data from the particular table, suppose let's consider if you query select star from table where name equal to y, y is available in the y is available in 2 records, I guess. Select star from name equal to y, and this is the y. The y is available in a micro partitions in micro partition 3 and then micro partition 4. By using a metadata information, instead of scanning all the micro partitions to fetch the where name equal to y records 2 records, instead of scanning all the records, directly it will go into the particular micro partitions and fetch the data for you. Then what is the advantage here? Suppose let's consider this. If we have a n number of billions n number of billions of records into the particular table, in such scenario, the one micro partition size will be the maximum 500 MB. Till 500 MB of data, you can able to store that data into the one micro partition. Suppose if our table will be having a data into a like 10 GB or 20 GB or 1 GB, 2 GB. Consider guys, based on your table size, those many number of with the 500 of micro partition, those many number of micro partitions will be allocated to one table. If n number of micro partitions are allocated to one table, if you are searching a data for the particular criteria, instead of searching a n number of micro partitions, with the help of metadata information, directly it will go into the particular number of micro partitions and it will bring the data for you instead of scanning all the micro partitions to fetch the particular number of records from the table. Directly with the help of metadata tables, directly it will go into the particular number of particular number of micro partitions and it will retrieve the data for you. So here you are saving here to scan all the micro partitions. Suppose let's consider if we have 1000 micro partitions, let's consider to bring the particular criteria of data are only some set of records from the table. Instead of scanning 1000 micro partitions or instead of scanning only 10 micro partitions, then do we have a difference or not? We have a difference. So by this way, so we can able to see very good performance in a Snowflake, guys. And also, is it similar to indexer? Is it similar to index? Yes, I will come next. So again. So based on your query and then based on the columns are using in your query. Suppose you have a table and you are writing a query on top of your table and frequently you are using some columns in your where condition. Still, to make the faster execution time of your query, you can able to create cluster keys on your table. When you create a cluster key on your table, when you create a cluster key on your table, the data will be sorted in a physical order. What is cluster key? Cluster key is one of the key. You will be creating a cluster key on a multiple columns. Usually, the columns will identify which are frequently used in the where conditions to make the searching criteria faster, so that with the help of cluster key, your query will be executing very faster and it will produce you a result very faster comparing to a normal queries. What will happen if you create a cluster key on a particular column? Suppose let's consider if I create a cluster key on a name column, the data will be sorted in a ascending order. And also the same sorted order will be stored in a micro partitions. the order will be, then now order will be different now. Order will be different now. So earlier we have seen, if you search where name equal to y, where name equal to y, so we have a two records. Earlier these two records are available in the micro partition 3 and then micro partition 4. Now the data has sorted physically, data has sorted physically, and then those two records are available in the only in one micro partition now, because the data has sorted. Earlier this y is available in one micro partition, another y is available in the another micro partitions. It requires to scan two micro partitions to bring the data. Now as you have created a cluster key on top of your table, due to that data has physically sorted, and then the y values are available in, because the data has sorted, the values are available in the one micro partition. Directly it will come into the micro partition 4, and then it will bring the data for you guys. Now suppose let's consider we are talking about only one micro partition here. In case of we have a huge number of data, n number of micro partitions are allocated. In such scenario, instead of searching a n number of micro partitions, if the data is sorted, the data will be available in the only fewer micro partitions. Directly it will go into the particular micro partitions and then scan and then bring the data for you guys. That's how we can able to see the robust performance improvement in the Snowflake. And also what will happen if the data is going to store in a column format? What will happen? See here, suppose if your data is split, if your data is stored under in a traditional format column and then rows format, what will happen to search the one record? Then it may need to scan all the micro partitions, because your table data has split into multiple micro partitions. I am speaking about the traditional way. If the data is split across like columns and the traditional format in a rows level, maybe the data will be split into a multiple micro partitions for one record. In such scenario, to bring the one record, you need to scan multiple micro partitions. To avoid that, the Snowflake is storing a data in a column format. See here, this is the type, this is name, this is country, date. The column is table structure is traditional format only. Table structure is traditional format only. If you query select star from table, you will get a traditional format. But internally, the way the data is going to store in a column format in a Snowflake. What is the advantage? What is the advantage? One second. Okay. Now, as data is stored, guys. Whatever we have a questions, we will discuss end of the session, please. So when the data is stored in a column format, if you want to search like a record, if you want to search a record where type equal to 2, it will if you search a record where type equal to 2, and then it will come into the first micro partitions, and it will scan only one micro partition, and it will bring the data type equal to 2 and then name a corresponding remaining column values 2a uk and then 11/2. So the advantage is here, as the data is stored in a column format, and then this data is available in only in one micro partition. It will come into the particular micro partitions and it will scan, and then it will bring the data for you. And suppose let's consider if the data is splitted and the data is stored in a traditional format. If the data is stored in traditional format, maybe the data will be stored split into multiple micro partitions. In that scenario, then so it needs to be search the data in a multiple micro partitions. To avoid that, To avoid that, to improve the performance of your IO request or to read the data from the Snowflake, the data is stored in a column format. So advantage is directly, if you query any value, directly it will go into the particular micro partition, because one row record is stored in one micro partition, particular row record. Because see this, if you see this value, this is a one record, first one and second record. This is a third record and fourth record, like that. If you query a particular record, the data will be stored one record in a one micro partition. Directly it will come into that micro partition and it will bring the data for you. So by doing this internally there will be a lot of benefits, guys. Internally there will be a lot of benefits like you are saving a lot of scannings, and you are avoiding a lot of scanning of the micro partitions. See here, data storage component. This is a storage component of the Snowflake. Load the data. Data will be stored in a continuous micro partitions in a compressed and then optimized way. Size of each micro partition is 50 MB to 500 MB. Data will be stored in column format. Structured data and then semi-structured data will be processed in the storage layer. See here, one micro partition size is 500 MB. One micro partition size is 500 MB. Suppose if you load 1 GB of data, into your table, then so 1 GB is 1024 MB. So now we require 3 micro partitions, because each micro partition is 500 MB. As you have 1024 MB of data in your table, so 3 micro partitions are required. Like that, suppose if you store a 2 GB of data into your Snowflake table, then it will require a 5 micro partitions. Like that, it will calculate and then it will split the data into those many number of micro partitions. So this is about the storage layer, guys. Any doubts in the storage layer? Tell me. Any doubts in the storage layer before going to query processing layer?
Sir, the only thing I'm a little confused is, like, we say that it's columnar, right?
Right.
So definitely it's, let's say, my predicate is, let's say, in this case, the primary key. So it's going to store all the columns contiguously, right, next to each other. So if it is doing that way, how is it storing the row? I'm a little confused. That's what I'm asking.
Can you repeat once again?
So basically it's a columnar storage, right, sir?
Correct.
So let's say my columns are, in this case, let's say we go over the type, right? Type is my column, and I have created a key. And you said we need to create a key, clustered key.
Yes.
So let's say 2, 4, 3, 2, 1, 10, 15, 20, whatever the numbers are. So let's say I created that. So in this case, it's storing 2. So it will say 2, 4, 3, 2, 3, 2 contiguously in one partition, correct? Right? So how is it storing the row also? I'm a little bit not clear.
See here, this is the data. This is the data.
Right, sir.
Before going to creating it, so here there is no primary key, there is no cluster key.
Right.
You can't refer to your SQL server, and so you can't assume in such a way. So you need to come out of that. Fine. Still, if we are in that comparison, then we will not be complete. We need to come out of that and then addict to the Snowflake environment. Now,
sure, sir.
Now see, I know your perspective. I know your comparison, how you are comparing. Even I also have robust experience in SQL Server. That's fine. This is our original data. Fine. Now we have created a cluster key on name column. Fine. Name column. Before creating a cluster key on your table, the data is stored in this format. Fine. Now, when you create a cluster key, on this name column, data will be first sorted. All the A all the A's will become A in a top, right? Ascending order.
Sure.
And then B, and then C, and then D, and then Z.
Correct.
Now the data is going to sort. Suppose let's consider. Now we have a 3 records with the A here.
Mhm.
Now we have a A. These 3 records will be stored. These 3 records will be stored in a first micro partition.
Okay, so you're saying the 3 records not only as the column, but the entire rows, but separately as columns will be stored in a micro partition.
See, rows means here this way, not this way. That's what.
Oh no, I get that, sir. Yeah. So basically columns A, and then whatever is the corresponding country 1, country 2, country 3, or whatever that is, date 1, date 2, date 3,
data will be coming under
data will be stored. So basically the entire record or the row will be separately stored as columns in the micro partition 1 based on the clustered key that we have created.
Correct. So that's what.
Yeah, I'm clear.
That's what I'm saying. We need to come out of the comparison. We need to come out of that world. We are in new world.
Sure, sir. It'll take me 1 or 2 days to get out of the hangover.
That's fine. Yeah. That's fine. Even see, because we are all experienced. You may having experience in one database. I may having experience in one database. But here is by comparing all the database engines, by whatever we have drawbacks in all the database engines, he has simplified. In the Snowflake to overcome all the issues. Whatever we need to simplify, he has simplified in the Snowflake. So that is the beauty we have in Snowflake. That's what I told. To come out of that old world, enter into the new world.
Sure, sir. It'll take time, but definitely it's clear now. Thank you so much, sir.
So let me transpose and stored in micro partitions. Guys, suppose if you have any questions, instead of writing a chart, just you can unmute and then ask, so that we can finish there itself. We can't type and then for you. See, yes, one of our associate, basically rows will be transferred as a column. Correct. Just now we discussed same thing and then stored in a micro partition. Exactly. Just now we have discussed the same way. The data is going to store. Bhavana madam, you are clear or still you have a gaps?
Yeah, I'm clear because I don't know anything. I feel this is easy.
No, that's okay. So see, that's okay. See, this is advantage for you because you don't compare with the apples and the mangoes.
Yeah.
Because people are having a robust experience in mango, but they are comparing. Now we are discussing about the apple, but they are comparing both and then getting the questions. That is not a problem because because we are human being, we will get doubts. You say you are a white paper, so you don't have any background of the database. At least whatever we are discussing here, you are getting or not? That is my question.
Yeah, I'm getting it.
Clear, right? You don't have any gaps.
Yeah.
Guys, specifically why I am asking Bhavana is she is from a civil background. She don't have any IT background. That's what I am asking. There is no other specific points. Fine. If others also, if you have any questions on the storage layer, you can ask me now itself. I can clear. If you all are clear, then we'll shift it to the processing layer. That is also a beautiful concept.
Yeah. So one final question, sir. So by default, it will be stored as rows, but if we cleared a clustered key, it will be stored as like this micro partitions.
Correct.
Okay, sir. Thank you.
Now, query processing layer. So this query processing layer is a completely hardware resource. You can note somewhere. So I am suggesting you while explaining the concept, better to prepare some running notes, make some note, make some date, make a heading, and then whatever we are discussing, just make some couple of points so that it will be remembered for you. Even I also share all the contents whatever we are going to discuss in the every session. But from you also, please prepare some running comments. At least if I ask tomorrow, then you will be able to recapture what we discussed yesterday. So from there we can continue. So that is the best practice, guys. Don't sit idle. Better to prepare some running comments, running notes. Fine. Next we'll discuss about the query processing layer. Query processing layer is the completely hardware resource to your Snowflake environment. We can call it as a virtual compute warehouse. virtual warehouse, virtual compute warehouse. Hardware, if I pronounce virtual warehouse or virtual compute warehouse, this is completely hardware resource to your Snowflake environment. In on-prem servers, hardware resources are physically installed or maintained, like CPUs, RAM, motherboard, etc. Without all these things, suppose let's say SQL server, on-prem server. Even though if you install your SQL server software in one physical server, if you don't have proper hardware resources configuration to your remote server, then your SQL server will not work properly. I will give you an example. If you to install a SQL server properly in your machines or in your server, the minimum configuration is 2 GB of RAM and then minimum 10 GB of hard disk. This is least minimum configuration to build the SQL software in your remote servers. And on top of that, whatever you do, if you submit your request, if you load the data into the SQL server, and then if you generate some reports on top of your servers, automatically whatever the hardware resources are configured in your remote server, RL server, or your machine, all those hardware resources are consumed by your SQL server. Without to execute your SQL statements, in your SQL server, it requires a motherboard and then CPU. It requires a RAM. It requires hardware resources. So, if hardware resources are not sufficient to based on your request and then based on your SQL server, then your SQL server will not respond properly. It will not work properly. Sometimes it will hang. It will not respond. It will go into a down. It will go into a it will go keep running. So like that, there we are going to set up everything physical components in on-prem servers. In case of a Snowflake environment, they have simplified like anything. Just the virtual warehouse, virtual compute warehouse is a hardware resource. Just these virtual warehouse we are going to create means before going to start the project based on our requirement. So who is going to design the environment there, like your database architect? We can able to create this virtual warehouse. How we are going to create a table, table name? Like that, we are going to create a virtual warehouse also in the Snowflake. There is no physical components for our hardware resources. Just this is also one of the object. This is also one of the object in your Snowflake environment. Just we are going to create a warehouse name. Then that warehouse will become a hardware resource to your Snowflake environment. For all your activities in the environment, you will be consumed this virtual warehouse. I will tell you. Yesterday I told you little bit knowledge on this virtual warehouse. Now I will tell you little bit more on this thing. See, we can able to create this virtual warehouse in a Snowflake environment. So as mentioned here, we can able to create a multiple virtual warehouse, for the multiple projects, and each project will be utilized. By their own individual virtual warehouses. And this suppose if we have 3 virtual warehouses, these 3 virtual warehouses are defined with the different sizes. This may be defined. See, we have a different sizes here. We have different sizes here: small, and then small, medium, large, based on your utilization, based on your requirement, based on your capacity. So the different virtual warehouse sizes will be created. Now we have I am giving example. We have a 3 virtual warehouses for the 3 projects. The one virtual warehouse is created by small size, and the second virtual warehouse size is defined with the medium, and then this third virtual warehouse size is defined with the large virtual warehouse. Because this first virtual warehouse is used by the project 1 based on their data load, based on their, see how actually we are going to decide all these things, how we are going to decide the hardware resource or storage component, usually in database world, how we are going to calculate all these things. Before going to start a designing of your data warehouse and your database, first we are going to analyze the requirement. So how many, maybe based on, I told you in the first class or second class, I guess, based on how many users are, one second. Do I closed or this one? See, yeah, this one. See, based on how many users are connecting to your servers, and then how many IO requests are submitting to, your data warehouse, and how many concurrent users are connecting to your data warehouse, how many users are generating a reports on top of your data warehouse, and how much daily, how many, maybe suppose let's consider there will be a assumption. Suppose if you check about the e-commerce portal, Amazon, maybe the Amazon management will have a assumptions like how many customers are daily the e-commerce portal is connecting. So based on the number of users and the number of transactions, by considering all these points, by considering, suppose if 1,000 users are connecting to the Amazon account, and then 1,000 users are browsing, and then 1,000 users are ordering the products in the Amazon account. Now 1,000 users are ordered in the Amazon account means now we have 1,000 transactions for a particular day. 1,000 transactions means 1,000 records. 1,000 records means what is the size? Maximum maybe 1 GB. So based on that type of calculation, now we got a 1 GB of data into the data warehouse for the particular day. And then how many users are connecting? 1,000 users. And then how many users are submitting their request? Other users. By considering all these things, we are going to decide a data warehouse designing capacity. What is the storage capacity, and then what is the hardware capacity? Like that, based on the requirement. So we are going to decide a virtual warehouse size, and then we will create as per our requirement. Now, project 1 may have the different criteria. Project 2 may have the different criteria. Project 3 may have the different criteria. Different criteria means their usage, their capacity. So based on that, we have created a multiple virtual warehouse size here. What is the advantage here to create the multiple virtual warehouses here? See here, as I am working in a project 1, and when I log in into the Snowflake account, DBA will restrict that I can able to see and then use only my project related virtual warehouse. So I can able to see my particular virtual warehouse only, so that I can use and then I can consume my virtual warehouse only, so that I can able to see the better performance improvement in all the activities, because hardware resource is not sharing to all the projects. This hardware resource is specific to the project level, so that we can able to see the very good performance. In case of on-prem servers, whatever we have installed the hardware resources, that hardware resources are shared across all the organization. In such scenario, we have a lot of drawbacks over there. To overcome that, here we are going to create a multiple virtual warehouse. And then we can able to utilize our own individual virtual warehouse only. We can able to see our own individual virtual warehouses only. So by doing this, we can able to see the good performance in all the activities. If project 2 associates are logged into the Snowflake account, they can able to see only their project related virtual warehouse. If project 3 associates are logging into the Snowflake environment, the DBA will do these type of settings. DBA will do these type of accesses. DBA will do these type of activities. DBA activities are these only. So which object is going to provide access to which user, and which access is need not to give the permission to the particular user. So the DBA will take care of all these things. So that you are logging into your Snowflake account, you can able to see your own virtual warehouse, and you are using that virtual warehouse, and then you can able to execute all your activities using that virtual warehouse only. And second point is the beauty of this virtual warehouse is, suppose yesterday as I mentioned, suppose we are doing all the activities for the particular day in the peak hours, in early morning or else in the late nights. Suppose if data loading is happening in your warehouse, comparing to regular activities, if the data loading activity is more and your virtual warehouse size is, your virtual warehouse is consuming more, and then whatever you have defined, the size with the virtual warehouse is not sufficient for your activity data load. In that scenario, directly you can come into virtual warehouse manually, and you can increase the virtual warehouse size to the next. If it is a small, you can increase to the medium. If it is a medium, you can increase to the large. By doing this, you are not stopping any process, you are not disturbing, you are not doing any mistakes here. It will do its own activity. You can't see, even while if you increase the manually the virtual size, it will not stop or it will not create any problem for the activities. It will keep executing the activity. Just it will allow you to increase the virtual size without impacting or without creating any problem. So that is the beauty we have in a virtual warehouse. And also, instead of increasing it, we have one more option. We have one more option with the virtual warehouse. Instead of increasing it manually the size of the virtual warehouse, we have one more option. Automatically, based on the requirement, based on the requests, based on the number of users, based on the number of concurrent users, based on the requests are available in the queue, automatically the virtual warehouse size will be increased. We have a second option also. We will discuss all these things in next session. How do we increase manually? How do we automatically it will increase? So this is about the query processing layer. And in storage layer, guys, in storage layer, suppose let's consider there is no limit for the storage layer here. Comparing to suppose if on-prem servers, in the on-prem servers, you will define the hard disk initially. If you define the hard disk to the some around 10 TB, if 10 TB is full, again still your ETL batch jobs are running, trying to load the data into the your SQL server warehouse in on-prem servers. If the hard disk is full, then your jobs will be failed or jobs will be keep running, and then it will run for the days and days until you increase the size of your hard disk. In Snowflake, there is no limit. Based on the requirement, automatically the size will be increased by Snowflake. So for that you are going to pay. That is different case, but it will not stop your activities. In Snowflake again, this query processing, this virtual warehouse hardware resources, and then this storage component, they both are separated here. Both components are working individually. There is no dependency between the one component to other component. There is no dependency between the one component to other component. They both are working separately, so that we have a very good performance improvement in the Snowflake. So this is about the query processing layer, guys. Any doubts in this query processing layer? Any doubts in query processing layer, guys?
So, sir, basically query processing is like you're saying, it's kind of easy to machines in terms of AWS, right? Easy to machines, right?
No, this is a purely hardware resource.
Hardware, okay.
Hardware resource. One second. See, this is a query processing layer. This layer is a hardware resource to Snowflake. To load the data, to load the data, to process the data, to process the IO request, hardware resources are required. Virtual warehouse hardware resource can create a multiple warehouse in a Snowflake based on the requirement. Can create each virtual warehouse for each project to improve the performance and make the independent. So we have two types of virtual warehouse. Those things and all we will discuss in next session in detail, very in detail about the virtual warehouse, how it looks like, how it will work, how the manually we need to increase the virtual size, how automatically it will increase the sizes. Those things and all we will discuss in next session. Completely, we will discuss one session on virtual warehouse only because that is important. That is the beauty of Snowflake.
Yeah, sure, sir. Yeah, thank you. Yeah, I
Yeah,
have some more
if-
questions, but I'll wait. Yeah.
Tell me if you have a doubts on this virtual warehouse, if you have a doubts on this query processing layer and the storage layer, you can complete now itself.
No, I mean, like, again, my bad mind, still sticks to that traditional on-prem warehouses, right? So obviously that's where my questions are coming. And
No
since I
problem.
didn't attend the first class, obviously I missed this part. So see, in my mind, whenever I say warehouse, I kind of like think of a dimensional, model in general, right?
Correct.
Yeah, and in this case, you're saying per project a virtual warehouse is created. That means you're saying the hardware resources basically are allocated and created per project that you are doing. It's not like, let's say I have an EDW, enterprise data warehouse, where I have multiple data marts sitting within the warehouse. So for me, the entire, on-prem, the entire infrastructure is the same. It's the same data center and all that stuff. But in this case, you're saying the hardware is per project or
Correct.
per, I won't say dimension model, but for now, I'll kind of like keep in mind whatever you said, but I'll wait for the next session also, sir. Yeah.
Okay.
Yeah.
Fine.
So the storage layer is where the dimensional model is set. Is that true? Then
Dimension model and all, see here you can't. That's what you can't compare those things and all. Here is whatever you store the data in a Snowflake, the data will be stored into the micro partitions. That's all I can say.
sure, sir. Yeah. Okay.
There
Yeah.
also,
I'll
see,
correct myself. Yeah. I'll update myself, sir. Yeah.
I understood your terminology there. We are going to store the data in a facts and dimensions, and then those are finally those are tables only, right?
Correct.
So those tables, if you see your SQL server, so we use the terminology facts and dimensions, and then measures, and then some facts, those things and all. But finally, those are those are multiple tables only internally. Fine.
Correct. It's only
So,
logical model. Yeah.
So internally, when you load the data into those factions or dimensions in the SQL server, finally the data is going to store least component in a SQL server is databases.
Correct. And file, obviously, at the end.
Databases. So the data file is the upper layer.
Right.
In data file, again we'll get the file groups with the file groups in the data file itself. We'll get the file groups. Within the file groups, we will get the extents. Within the extents, we will get the database is the least storage component.
Lowest grain in the component.
Yes,
Yes,
like that, here micro partitions are the storage least component. So there is no again these data files, these extents, the entire thing are gone here.
Sure, sir. Got it.
Gone here. There also finally data. We are speaking about data only there. If you speak about the data marts, if you speak about the dimensions, if you speak about the multiple dimensions, if you speak about the multiple data marts or multiple data warehouses, again the combination of the tables, again the same story only. Again we are speaking about the data will be stored in the database, and then data file logically divided, and then finally it will go into the databases only directly in SQL Server. Correct.
Sure, sir. Just one last question on that. So when we are actually talking about database storage, right? So S3, I mean, in AWS, it's S3, right? So in S3, what we are saying is the data will be stored in terms of files or, Parquet files or whatever it is. And ultimately, physically, but logically, they'll be stored in micro partitions.
Here,
Okay, thank you.
here physically they are storing in micro partitions.
Oh, physically in micro partitions.
Physically in micro partitions, there is no data file, there is no log file kind of things here.
Okay.
Directly it will go into the micro partitions only.
Okay, and those micro partitions created on S3, for example.
In Amazon, in Snowflake.
If I'm using AWS, yeah.
Correct. Clear.
Okay, sir.
Now we will discuss about the cloud service layer. This cloud service layer is the top layer in the Snowflake. See, whatever we are discussing on architecture, it is important. Maybe you will get a questions on interview on 1 or 2 questions. They may ask you indirectly. They will ask the questions. But whatever you will get the questions based on our discussion only. If you understand all these points, then you can able to answer. That is a different story about the interview, but try to understand the concept. Cloud service layer here. This cloud service layer is the topmost layer in the Snowflake architecture. So what this cloud service layer will do? So this is the important and topmost layer in the Snowflake. Why? Because very first what it will do, if any number of users are logging into the Snowflake account, the user level and then access level will be checked through this cloud service layer only. Whether the valid user are logging into the Snowflake, if invalid user is logging into the Snowflake, and what are the access, what are the roles are particular user is having, all these checks are done by this cloud service layer only. That is authentication and then access control. And second thing is, whenever the user is submitting a IO request, what is the meaning by IO request? Input and output. Input is user is submitting a SQL code, SQL query to your user is submitting a SQL code to your Snowflake environment to read the data from the particular table. Whenever the user is submitting a IO request to the Snowflake environment, very first layer, the cloud service layer is received by very first layer. Cloud service layer is received your IO request, and it will check all your SQL code syntactically. If everything looks fine, then it will pass. The IO request will go into the next query processing layer. In query processing layer, we have a cache memory. There, suppose if already the result is available, so from this layer only, the data will be retrieved, and then this data again it will go through the cloud service layer, and then from here the data will be returned to the end user based on the IO request. What is the meaning of this? Whatever the IO request is submitted by the user, it needs to be for sure go through the cloud service layer and return the data through the cloud service layer only, end to end. The user is submitted, and then internally it will pass through the cloud service layer, and then it will pass the query to the next query processing layer. If the data is available, resultant data is available in the cache memory, it will pick from that cache memory. If not, then again it will go into the storage layer where the physical data is stored in the micro partitions. From there, it will pick the data and then it will submit it to the cloud service layer. From here, the data will be returned to the end user. So this is one of the role it is playing. Second thing is, and also it will take the transaction managers. See here, whatever the data is going to load into the Snowflake environment, the data will be stored into the storage layer. Once the data is stored in the storage layer, then it will commit all those transactions. If anything, suppose like implicit transactions only, suppose if anything happens in between, the data loss process is stopped, that transaction will be rolled back. The committing, rollback, and saving the data, everything will be taken care of by your transaction manager, and which is available in the your cloud service, your cloud service layer. Again, whatever I told, the user level, roles level, security level, what is the access, whether do I need to log in, do I need to permit to log in the particular user into the Snowflake environment, whether do I need to create the object into the, do I need to allow the particular user to create the objects into the Snowflake environment. So based on the roles, based on the access, everything will be taken care by this cloud service layer with this security layer. This security means the user level access and then security level access, and allowing to create the object, allowing to modify everything taken care by this cloud service layer. Overall, I can say this cloud service layer is the very first. Whatever we spoke about the metadata tables, those metadata tables also managed by this cloud service layer only. So that this cloud service layer is very much important and very much top layer in the Snowflake environment. If I say the nodes, if I go to the nodes, see here. Top layer, without this layer, Snowflake will not work. Once you submit the SQL query, query will be passed from this layer and will submit to the storage layer, and cloud service layer will return the data. Taken care, access control, this thing, metadata manager, infrastructure manager, security, XYZ. So this is about your cloud service layer. So complete. So this is about your Snowflake architecture. Now, if you have any overall questions on this architecture, you can ask me.
Shekhar, this is Bhavna. So
Yeah, tell me about.
yeah, I just missed one point when you were explaining the query processing layer. You said no dependency between database storage and query process. That part I just I think one or two sentences I missed. Can you please let me know what?
See here. This query processing layer means hardware resource. The storage layer means database storage. Here, when you submit any request to the Snowflake environment, if suppose the request is data load, you are loading a data into the one table. So in that scenario, see, data load or data retrieval or data generation, whatever it is, you require a hardware resources for sure. Without your hardware resources, you can't do any activity in any database, not only Snowflake, any database or any data warehouse. Here also, this hardware resources and then the storage component, both are working independently internally. You will not see those things and all independently. They are working independently. They have divided and they have made these two components separated to work for your activities. There is no dependency between the storage layer and there is no dependency between this hardware layer. They are independent. They are work independently. That's it. Internally, we can't see all those things under Bhavana.
Okay, got it. Thank you.
Any other questions?
So when we say metadata storage, sir, so all the DDLs and all the table structures and everything will be there.
Correct.
Okay, so the physical data itself is stored in the database storage.
Correct.
But all the metadata and everything or the interface. So cloud services is my interface. Whether I'm actually creating a new database, where I'm actually firing a query or anything, or writing a start proc, I mean, traditional way, for example, all that stuff will be in the cloud services. That is my interface. And from there, I'm submitting it, the job or whatever it is, and it's taking care of all that stuff. Query processing is independent. It's a virtual warehouse. All the infrastructure is automatically scaled or based on however it works. Obviously, it's not, as a developer, I'm not looking at it at this point, but so definitely that will be taken care of, and my data will be ultimately stored and retrieved from storage, except the fact that if there is something already ran and it's in the cache, it will be retrieved from the query processing layer.
Correct.
Okay, thank you, sir.
Any other questions? Maybe.
I'll go through some more questions about the optimizer, sir, later. But is it like creating a SQL plan or something like that, just like in our traditional SQL warehouse?
Yes. Here also execution plan, everything we create.
Okay, so yeah, we can deal with that. I mean, later.
So maybe we have completed 3 demos. I don't know. From tomorrow they will change the link. You need to for sure get registration with the institute people, so that when you make the registration, then only you will get the new link from the institute. They will allow usually 3 free demo classes. From 4th class onwards, or maybe they are asking for the registration and then get the new link kind of thing. Just be touch base with the institute people.
Yes, sir. Nobody called me actually from the number, and I know you're recording this, so I cannot divulge a lot of details. But nobody called me, and I'm trying to. I want to send it through like Western Union or something like that, because obviously I don't have a credible bank accounts and stuff like that in India. So how does that work? Like so that's why I want to reach out to them. How to send the money?
You need to touch base with the institute only. You will get. I don't have the details.
Okay, so the numbers that are listed in the email.
Yeah, you need to touch base with them only, or else they will get back to you your number or your email. They
Yeah, I
have
mean,
they
my
have
email
sent
and number is there, obviously, but I have not heard back anybody. So I can reach out. I mean, just not to discontinue, obviously, the class.
see here, they have sent the details in the chart also, I guess.
Right, sir. So I'm just asking, like, if I send through some Western Union or something like that, how do I
For
mention
those
my?
things, for those things, and you need to touch base with your institute people only.
Okay, sir. Tomorrow morning I'll try to call them. Okay, sir.
Yes,
I'll
yes.
see if they can come in touch.
Fine, fine. Any questions, guys?
Shekhar, I have one last question. So in the whole class, I noted few things like when you said we discussed something about cluster key. So in the table, the information is stored in the columns again, right? Data. So you said based on the cluster key, the data is retrieved and you get the required information. So my question is, how cluster key is created?
Bhavana, so don't get much into the things because you will get confusion. Let go through the one by one. If the sessions are completed, you will try to get the understand. So this is how looks like overall picture I have given. The piece by piece we will go through each session. So by that way you will get all the details. Then I can suggest in such a way that is better.
Okay.
If I explain all the Bahubali 10 parts in the theoretically, then you will get a confusion.
Oh, no issues. No, I was
Correct,
just.
no? You understood?
Yeah, I thought you have already explained what is cluster
No,
key.
no. This is the architecture.
Okay.
So I don't have any problem to give the proper explanation, but you don't get even if I explain very clearly also, you don't get because you don't have idea. So instead of that, let us travel through the sessions. In between by each by session, if you get any doubts, then but end of the session you will get all these details. Then it will be easy for you to digest the thing. That's what I can suggest you, Bhavana. What do you say?
Yeah, sure, definitely. Thank
Correct,
you.
no?
Yeah.
Any doubts?
So today is the last demo, and from
That's
tomorrow
what yeah, institute people will allow only 3 demos. That's why I am suggesting to touch base with the institute people today itself. What they will say, based on that proceed further. I don't have any problem if they allow you. I don't have any problem. Daily I am taking the session. I am explaining the things. Even like you also, I will also get the link only in my email. Like you also, there is no special link for me. There is no special link for the students. Same how you are getting a link, I will also get the link as per the institute instructions. I need to go. That's it. If they give tomorrow leave link, I need to log into that leave link. If they are not going to share, then I need to log into this one. That's how you are going to follow. Even I am also following the same thing, Bhavana.
Okay. So one last question: are you also based in India or some
Hyderabad only.
Hyderabad. So one last question is like, are you also taking classes in institute?
No.
You are only taking online.
Online only because Bhavana, even I am also working. I am also very much busy.
Okay.
I can't travel to the institute and it will take the half an hour going and then from there. So it is becoming difficult.
Yeah, it's a hassle. But I was just wondering because sometimes the home environment doesn't suit for classes. Sometimes not. So I was just
okay, but that's I understand your problem. But you don't worry. Whatever you will get a jobs, whatever you will get a questions, whatever you will get a things, then I am here to support you. Even I will share my personal email ID and then personal numbers also. So you can reach out to me anytime and then get clarified everything.
That's so nice.
So that thing I can give you the content also. On top of that, so whatever you require, I can support you. So what else you required?
That is it. Because I was just wondering sometimes if there is any gap that needs to be, directly contacted to the teacher. So I don't know how institute is going to help. So I was just wondering.
No, don't worry. I will share the details. You can directly contact.
Thank you, Shekhar. That is it for now. That is it. Thank you.
Fine, guys. If you don't have any questions, then we can close the session for today, and then we'll meet same tomorrow at 7 a.m.
Thank you so much, sir. Yeah.
This weekend I'm planning to take the sessions actually Saturday and then Sunday. Please plan accordingly.
So it will be 8:30 to 9:30, sir. Same time? I mean, sorry, whatever,
Same,
7
same,
o'clock
like,
India.
like,
Yeah, okay.
yeah, same like 7 a.m. IST. Little
Okay.
bit today we are going to complete 1 hour. Maybe it will be extended to another half an hour.
Okay. Yeah. The sooner the better, sir. That's all. Thank you.
Yeah.
It's already 9:45 here in the night. So yeah.
Yes, same time, 7 o'clock, 7 a.m. IST I'm going to start. And 8:30 we are going to close. That's it.
Okay. Sure, sir. Thank you so much, sir. Yeah.
Thank
I'll
you,
have more
guys.
questions, obviously, but I just want to make sure I enroll in the class and then ask you all those questions.
Fine, fine.
Yeah.
Thank you guys. Have a nice day. Bye. We'll meet tomorrow.
Bye, guys. Have a good day, sir. Bye.